Good morning and welcome to another Consupport video. This one is on solutions of systems of equations. All right, let's go. All right, so this one says here that we've got two equations of a line, and let me write those down for you guys first. All right, so basically when you're looking at these two here, they're asking, is 5, 1 a solution to the system? Now, what it means to be a solution to the system of equations is that this ordered pair 5, 1, x value of 5, y value of 1, is not just a solution to the first line, but also to the second line. So since it's just a yes or no answer, you could just literally say, all right, let's plug these values in and see if we get a true statement. So if you look at that first one, it's -5 times y equals -5. Well, the y value would have to be what? 1. So -5 times 1 is, in fact, -5. So this is an eligible answer. Let's take a look at the second one. The x value is 5, so 7 times 5 is 35. And the y value is 1. 6 times 1 is 6. So it'd be 35 plus 6 is equal to 7. That's not true, right? So we know that this 5, 1 ordered pair is only a solution to the first line, not the second. So is it a solution to the system? No. Now, if I wanted to solve the system and find an ordered pair that would be a solution to the system, the easiest way to do this one would be actually to use a method called substitution. So you would divide both sides by -5 here and find out the value of y. And as we can see, value of y should be 1, right? Just like we saw here. So the y value of that ordered pair is correct, right? It should be 1. But now we would take that y value, plug it into the other equation, right? Substitute that y value for y right there. So we're going to replace y in the second equation with the y value from the first equation. And then you would be able to solve for the solution to the system. So watch. 7x plus 6 times 1 equals 7. 7x plus 7 equals 7. Minus 7 to both sides. And you get 7x is equal to 0. And then divide by 7 both sides. And x is equal to 0. So the ordered pair that is a solution to both of these is actually the ordered pair 0, 1. So it still works for the first equation, but now it also work for the second equation, because when y is 1, let's see, when y is 1, 6 times 1 is 6, and x is 0. That's not true, actually. Let's see, what do we do wrong there? I see what I did wrong. It should have worked, but I was sloppy here. It's not 6 plus 1, it's 6 times 1, right? It's early in the morning, so sorry, guys. Anyways, you guys can see here that this is going to work just fine now. I just made a silly error, which is easy to find once you know what you're looking for. So that's why we check our answers, right? So we can find our mistakes. So in this case, we know that this is now going to be like so. So when we get this, it's going to be 7x is equal to 1. And then you're going to divide by 7 both sides. And you're going to get an answer of 1/7. And that means that the ordered pair that should be a solution to both is the ordered pair 1/7, 1. And when we think about that one here, right, the y value of 1 works because basically this is just a line at y equals 1, right? And then over in this one, it works because when you have 1/7 of 7, that's going to be 1. And then 6 times 1 is going to be 6. So 1 plus 6 is going to be 7. So this would work. This is the solution to the system, not 5, 1. Anyways, so a little bumpy there because I was being sloppy, but I think you get the idea, right? So you can solve any system by using this method called substitution, where you get one of the variables in terms of the other and then replace it in the other equation, just like I did. But in this case, you don't have to. You just have to go 5, 1 is a solution, yes or no, and then move on. All right, the next question we got here. All right, so let's pause it. All right, so I paused it just so I could write out the steps so you can see the whole process. So the ordered pair that you're checking to see if it's a solution is the ordered pair 2, 3. So basically you're saying, is 2, 3 a solution to the system? In other words, is it a point that exists on both of these lines? So you would just check with 2, 3, where the x value is 2 and the y value is 3. So let's do that. So you got 2 times whatever x is, in this case 2, minus 3 times whatever y is, in this case 3, is equal to -5. does that give you a true statement? Well, that's 4 minus 9 is equal to negative 5. And yeah, negative 5 is equal to negative 5. So that would work, right? Because 4 plus negative 9 is negative 5. And then on this one, you check the same thing. So you'd say, all right, is 4 times the quantity of 2, which is the x value, minus 4 times the quantity of 3, which is the y value of the order pair, equal to negative 4. Well, 4 times 2 is 8, and 4 times 3 is 12, so that'll be negative 12. And as 8 take away 12 equals to negative 4, that's the same as 8 plus negative 12, which is negative 4. So yeah, that would work as well. So this time, the ordered pair 2, 3 is a solution to the system because it's a point that exists on both lines. So we would say yes. Okay. All right, let's check the next one. All right, so I set it up for you here. So we're going to check to see if 2, 2 is a solution to both of the lines, hence a solution to the system. You're looking for the intersection point between the two lines, which is basically an order pair that exists on both of them. All right, so in this case, we're going to check the order pair 2, 3, where x value of 2, y value of 3. So let's just plug it in and see if we get a true statement. So we get 3 is equal to negative 4 times the quantity of x, which is 2, and then plus 6. And we're going to see if this is a true statement. So 3 is equal to negative 4 times 2 is negative 8, and negative 8 plus 6 is negative 2. So right off the bat, we can see that on the first line here, this ordered pair is not a solution. So this doesn't even exist on this first line, let alone on both lines. So this is a no. All right, so the next one. All right, so on this one here, we have y equals negative 4x minus 5 and y equals 3x minus 2. We're going to check to see if 3, 7 is a solution. In other words, a point that exists on both lines, a solution to the system. So we have an x value of 3 and a y value of 7. Let's plug it in and see if it works for the first order pair, first linear equation. So we have a y value of 7 is equal to negative 4 times the x value of 3, and then minus 5. Is this a true statement? So this is 7 is equal to negative 4 times 3 is negative 12. Negative 12 minus 5 is the same as negative 12 plus negative 5. So what we get here is 7 is equal to negative 17. Obviously, that's false. So we know that this is not an ordered pair that's a solution to the first equation. So it definitely can't be a solution to both. All right. So we know this is definitely a no. All right. Now, if you wanted to find out what the solution to the system is, you have the y equals already. So this is a nice, easy one. You can just set the y equal to the y. So I'll show you this method. This is called the equal values method. So all you got to do is just take the y value and replace y with it. So you're literally going to just substitute in the value for y into the other equation and then solve. And that's going to give you the x location where the y's are the same. So let me show you how that looks. It would be negative 4x minus 5 is equal to 3x minus 2. And then you can solve that for the x position where the y's are the same. In other words, the x value on the order pair. So let's solve it. We're going to add 4x to both sides. We're going to add 2 to both sides. You're going to get negative 3 is equal to 7x. We're going to divide by 7 both sides. So x would be equal to negative 3/7, which means that the ordered pair that's the solution to this system would be the ordered pair negative 3/7, comma something, right? And we got to figure out what the y value is. Then you just take that negative 3/7 and plug it into either equation. Doesn't really matter which one. Let's use the one on the right. So we can see that y is equal to 3 times negative 3/7 minus 2. That's y is equal to negative 9/7 minus 2. And that's y is equal to, that's the same as 1 and 2/7. So that would be negative 3 and 2/7. So our order pair that would be the solution to the system that would work for both lines is actually this order pair, negative 3/7 minus 3 and 2/7, or negative 3 and 3/7 for the y value. So that would be a line, an exam answer that works on both. So we know that we plugged it into this one, so we know it works there already. And all you do is just to make sure it was a solution, you take these two and plug it in and see if you get a true statement for the other. So let me just show you guys how that would look. So let me do a check right here with y equals negative 4x minus 5 and make sure that it works for both equations because it should. And so now we do a little check. We say, all right, let's check this. So we know the x value should be negative 3/7. The y value should be negative 3 and 2/7. So negative 3 and 2/7 should be equal to negative 4 times negative 3/7, and then minus 5. And so this would be a negative 3 and 2/7, which is just going to stay negative 3 and 2/7, is equal to a positive 12/7, right? Because negative times negative is positive, and 4 times 3 is 12, minus how many sevenths here? And you're looking at 5, which is going to be 35/7, right? Because 7 times 5 is 35. And now what you got is you got negative 3 and 2/7 is equal to 35 take away 12, because negative wins by that amount. Well, 35 take away 12 is going to be 8 to get to 20, and then another 15. So we're looking at 23. We have 23/7. And how many times does 7 go into 23? 3 times. With how many left over? 2. So you guys can see that these are the same. So that's how you would do it carefully from beginning to end if you were trying to find the solution without giving it one to test. And the correct answer would be this very unusual ordered pair here. And that's how it works. But yeah, regardless, we know that 3/7 doesn't work. So that's a no. And that's how you do these problems. I wanted to give you an example of how to solve it as well as check it, so you know how to check it and how to solve it, right? So if you're just checking it, it's easy. Just plug it in and see if it works. If you're solving it, then use the substitution method. It works really well.